Now let's do an example of how composite functions can be applied. So example number 1 is that given f of x is equal to x minus 4 and g of x is equal to 3x plus 1, we have to determine f of g of x and g of f of x. Let's go ahead and just rewrite that so that I take the circle and replace it with the bracket first. So I have f of g of x. And as you can see here, the domain for my function f is my g of x function. So I'm going to first replace g of x into this bracket and write it as f of, so my g of x function is now 3x plus 1, so I'm just going to write that down here. So that's 3x plus 1. And what that means is that I'm going to replace all the values for x in the function f of x for 3x plus 1. So anytime I see x in f of x, I'm going to now write it as 3x plus 1. So this x is now replaced by 3x plus 1. And I'm just going to go ahead and copy the minus 4 down, and I'm going to simplify this expression. That becomes 3x minus 3. So in other words, f of g of x is equal to 3x minus 3. Similarly, we're going to do the same thing for part B. I'm going to replace the circle with the brackets first, so it's written as g of f of x. And I'm going to replace f of x with a function that's given to me as x minus 4. So g is g of x minus 4. And now, anytime I see x in the function g of x, that is now going to be replaced by x minus 4. So I'm substituting in my f of x function, which is x minus 4, into the value for x in my function g of x. So here I have 3 times x minus 4 plus 1. So just expanding that out, that's 3x minus 12 plus 1, which is equal to 3x minus 11. So I can rewrite this as g of f of x is equal to 3x minus 11. I'm just going to direct your attention to the bottom question here. It says, what do you notice about f of g of x and g of f of x? If you notice that they are actually not the same, because of the fact that my composite functions are not computative functions. Computative functions basically means where the order does not matter. So for example, addition, if I have 2 plus 3, addition is a composite function because of the fact that the order in which I add numbers does not make a difference. So 2 plus 3 is the same thing as me saying 3 plus 2. Similarly, multiplication is also a computative function because the order in which you multiply numbers does not matter either. So 2 times 3 is the exact same thing as saying 3 times 2. However, subtraction and division are not computative functions because the order in which you subtract or the order in which you divide numbers do not, the order in which you divide and subtract numbers does actually matter. So if I have 2 minus 3, that is not the same as 3 minus 2, or 2 divided by 3, and that's not the same as 3 divided by 2. Similarly, composite functions are not computative functions because f of g of x is actually not equal to g of f of x. So the order in which you apply your composite function does make a difference.